All right, today's lesson is 6-2, solving systems of equations by substitution. All right, so the whole chapter we're going to be solving systems of equations, but we're just going to learn different methods to solve them because giving the two types of equations, we have one method might be easier than another. So first of all, let's figure out what substitution is. Okay, so substitution is an algebraic method used to solve a system of equations to obtain an exact solution. All right, and an exact solution is what's key. All right, so for our first example, we're going to go ahead and solve this. So there's a couple of things we want to look for when we're solving equations by substitution. The first thing is one of your equations already solved for a certain variable? So if we look at this first example, notice how the first equation already says x equals 4y. Okay, so it's like our first step is done. So I'm going to write the steps down over here. You can write them anywhere you want to on your paper. So we have to solve one equation for one variable. Now notice I did not say you have to solve for x or you have to solve for y. You get to pick. All right, so our first step in this first problem, it's already done. The second step is to substitute I guess I should say first equation into second equation. So this says x equals 4y. So I'm going to write my second equation, but everywhere I see x, I'm going to replace it with something else. And what I'm going to replace it with is whatever that first equation tells me to. What says x is equal to 4y? So everywhere I see an x, I'm going to substitute in 4y. And now what you should notice is this whole equation has nothing but y's in it. So we can solve. So I'm going to write and, whoa. Hang on, I moved it down. Or I moved it up. There we go. So I'm going to write and solve. All right, so I'm going to solve this. I'm going to get 16y minus y equals 75. And then I'm going to get 15y equals 75. And then if we take 75 divided by 15, we get 5. So y is equal to 5. So we have half of our answer because we need to remember back to the last lesson that the solution is an ordered pair. Okay? So now we're on our step 3. Substitute answer. You can really substitute into either equation. I guess I should write either equation and solve for remaining variable. Okay, so I'm going to substitute this into the first equation because if you think about it, this right here was our second step, that up there was our first, because the first equation already says x equals 4y. So it's already solved for x. So I'm going to take 4 times 5, and we get that x is equal to 20. So our final answer is 20, 5. And that one is all finished. So a way we could check this is to substitute that ordered pair back in for x and y. If we get a true statement, like the left side of our equation is equal to the right side, then we know we did it right. If we get a false statement, we would have to go back and double check. All right, so now our second equation, or our second example. If we look at this one, I don't have just x equals something or y equals something. But what I do notice, and this is what you need to look for, is look at all of your variables. Look for the variable that does not have a coefficient with it. So the one that does not have a coefficient is that y in the top equation. So I'm going to go ahead and write my top equation down. And I'm going to solve it for the easiest variable. So you pick the easiest equation. You pick the easiest variable to solve for. And in this case, the easiest variable to solve for is y. So I'm going to solve that for y. So I'm going to subtract 4x from both sides. So y equals 12 minus 4x. And we could have put negative 4x plus 12. All right, so now my next step is to take my second equation, because I can't use the same one. If you use the same one, everything's going to cancel out. But everywhere I see y, I'm going to substitute that in because it tells me y is equal to that. So that is going to go right where y should be. So I'm going to get negative 2x minus 3. Don't forget parentheses. Times the quantity 12 minus 4x. And then finish your equation out. Equals 14. Now solve. So negative 2x. Don't forget the negative. So minus 36 plus 12x equals 14. So I'm going to combine my like terms. So 12x minus 2x is 10x. Minus 36 equals 14. I'm going to add 36 to both sides. So 10x is equal to 50, which means x is going to equal 5. So we're halfway done. Now, I could substitute this into either of the original equations, but where I like to substitute it in, since I already had to solve it, I'm going to substitute it in right there. So now this is my third step. So y equals 12 minus 4 times 5. So I get 12 minus 20. So y is equal to negative 8. So my final answer, because remember, the final answer is an ordered pair, is 5 comma negative 8. Okay, so that's how we solve using substitution. So as you go through this today, I want you to think, hey, do I like this better than graphing, or is it about the same, or do I really like graphing better? The better part about this is that we're getting an exact answer every time. I don't have to estimate where it is on my graph, but everybody has their own preferences. So take a moment, try the your turn, and then come back and double check your answer. All right, so for the first your turn, you should have gotten 1, 2 as your ordered pair. And to double check these, substitute both ordered pairs back into the equations to make sure you get 2 true statements. All right, on to part B. So this ordered pair, the solution, is negative 3, 2. All right, so hopefully you were able to get that one correct. So let's move on to the next example. So it says use substitution to solve the system of equations. So here's my 2. You don't have to rewrite them vertically. Sometimes I prefer to, but you are more than welcome to keep them written horizontally there. All right, so now I'm going to pick this equation. And now neither my x or my y have a variable in front of them, so you just get to pick your favorite. So really, you could solve yours differently than, say, 3 or 4 other people, and you all should get the same answer. I'm going to go ahead and solve mine for y since we're used to that. So we're going to get y equals negative x minus 2. Now I'm going to need to substitute this into my other equation. So 2x plus 2y equals 8. But everywhere I see y, I'm going to do negative x minus 2. And now solve. So 2x minus 2x minus 4 equals 8. 2x minus 2x, well, they cancel. So I'm left with negative 4 equals 8. What? Does negative 4 equal 8? Negative 4 does not equal 8. So if we think about this, hey, this is still a system of equations. And last section, we learned that there are 3 different things that could happen with our systems of equations. We could get one solution, like we've been getting, but we could also get no solution. So when we go through and we solve it and our variables cancel and the left side does not equal the right side, we get no solution. Whoops. So the other thing you need to think about, if we can get no solution, that means we can also get many solutions. So many solutions, and I'll just write this here, is if, say, I got 10 equals 10. So the variables cancel, but the left side equals the right side. So it just goes back again to that chapter 2 where we first learned how to solve equations and what happened when we solved those equations and the left side equals the right side. It was many. When the left side did not equal the right side, it was no solution. And we can just think about that graphically. Graphically, what that means is that for no solution, I'm going to have 2 parallel lines. For many solutions, I'm going to have one line that's right on top of another line. All right, so this is the last your turn. So go ahead, try it, and see what happens. Oh, so we got the left side does equal the right side. So we know this one is many solutions. Okay, and you can see that sometimes, unfortunately, we are going to get fractions, and you're going to have to just work with them. I would encourage you to keep the fractions because if you look in this case, it's simplified to end up being a whole number. Most times it will. Sometimes it will not, but most times it will. However, if we were to have changed that to a fraction and I just did, say, 0.6 instead of the 0.6 repeating, if I take 0.6 times 6, I get 3.6. So do you see how 3.6 is pretty far off that we would not have been able to get the right answer? So to combat that, I would recommend that if you get like 2/3 or 1/3 or anything that has a repeating decimal, type in several of those variables, or not variables, type in several of those numbers. So instead of 0.6, do like 0.666666666, just do a whole bunch of them times 6, and then you actually end up getting 3.99999 and a whole bunch of 9s. And then you would know that, hey, I need to round that to 4 because I rounded my decimal. All right, so that's today's lessons.